Hi guys, welcome back to Libris Custom Knives. This is part 10 of building our heat treatment oven. Yesterday we had our first quite successful test run, and today what we'll have to be doing is we'll have to be disassembling the oven again, fixing that big nasty gap that you saw that we have, and hopefully finalizing everything. Okay, so let's get started. Okay, there we are. A couple of things we need to do. First, we need to take off the lid and investigate what's going on inside. Second thing is we actually need to repair the door interlock because I managed to break that while I was doing everything last time. Okay, so these are the two big jobs that are in for today. So let's get started with those. Okay, so there we go. We've taken the lid off, and of course the first problem I have is what on earth to do with all this vermiculite that's in there. And if I just take the stock bricks off, it's just going to pour right into my chamber, which is not a good thing. So what I've decided to do is I've taken my Hoover, my vacuum cleaner, and I've cleared it out. I've cleaned it up as much as I could, so the chamber is maybe a tad dusty, but it's perfectly clean. And what I'm going to do is I'm going to simply Hoover all of this up, and afterwards just pour it straight back in from the Hoover. I'm just removing the roof. Also, one thing I did forget to mention in the last video, and you might have seen me do this, is in the corners where I had to put a lot of vermiculite, what I've done is I've bulked it up with all the offcuts of the bricks that I have. I didn't throw any of them out, just to sort of lessen the amount of vermiculite I had to use, because I had two 5-liter bags, and as we all saw in the last video, that wasn't enough. Okay, what I've decided to do, basically the problem I had is that some of the vermiculite was also leaking out down the front, okay, and of course there's a couple of gaps behind there where, for example, I did not notch the back bricks, okay, so that should be another incentive for you to do that. What I will do, I think, is I'll use the glass fiber rope, okay, and I will cut a small bit of it just to go in there into the very corner. I'm not using this for insulation as such, I'm using this to keep the vermiculite from pouring out again. And I'll probably use it up in all the corners in there too. Okay, that should help me have the situation under control. I don't think I'll need to use any adhesive or anything. I'm just going to use sort of a pressure fit to make sure that the rope stays in place. Okay, and once you've cut it, the rope will want to start to fray, so you don't want to be touching it for too much after that. So all I'm going to do is I'll set it into that groove and then ram my bricks against it, and it should provide a seal through which the vermiculite shouldn't be able to escape anymore. So, a couple of things that need doing. First thing is these 3 back bricks will have to all be squeezed together once I'm pouring the vermiculite in. Okay, as well as the side walls will have to be squeezed in relation to one another and the roof whilst I'm putting the vermiculite in the sides. And that will hopefully close up any of the big gaps that we had. Okay, let's have a look. Now, don't forget, of course, I also have this rope in there, so that effectively moved this whole wall back. You may remember we had a gap right here. I tried to annotate that in the last videos. And now, that gap is pretty much closed up because of this wall moving back. Obviously, something wasn't quite 100% square, and things got out of alignment at one point or another. There we go. I have this little piece of aluminium that I've bent into a V shape, and I'm just going to simply jam it in there. And that will keep the brick nice and true. Okay, and this one over there seems to be alright. It seems much better now, but ideally I could have something behind that brick as well. And now that should actually provide us with the support we need for those particular bricks. They shouldn't be falling down on us again. And as well, once the door closes and provides pressure up down here, it should squeeze those bricks against the back wall even more. At the same time, I did notice a little bit of vermiculite leaking from the side of this wall. So what I'll do is I'll cut off a small piece of this rope again, and I will actually sort of ram it in there with a screwdriver. Okay, there we go. That should provide it with plenty of clamping pressure against one another, and in theory should keep more of the heat in. However, before I put everything on, what I want to do is I want to test fit the door. Go on its hinges, and there we go. Right, okay. One thing I am seeing over here is that I will need to add the rope to the actual door as well, because by the looks of it, there's going to be a bit of a gap now because these sidewalls have been pushed back. Okay, what we do need is we need another piece of that glass fiber rope to go against these bricks over here, because we don't want any of that vermiculite once again leaking out. So we're gonna make sure we do this next. So okay, well, there we go. My hoover is pretty much full to the brim of vermiculite. So I just need to find myself some sort of a cup or something to start pouring it back in. There we go. All I'm using is a regular cup to get some vermiculite and just pour it in. There we go. I've put a couple of the offcuts that I had in that corner, and now I'll just continue pouring the vermiculite into that corner as well, and afterwards I should be able to release this clamp without everything falling apart. There we go. Okay, so there we go, we have vermiculite in both corners. Let's give this a shot. And there we go, I managed to release it and nothing fell apart, which is a good thing. There we go. I've just filled up the sides of this wall as well to make sure that it maintains everything together. And now you'll be able to see I still have a bit of a gap over here. However, that gap should, in theory, be properly filled up with vermiculite afterwards. And just to be double sure, I'll put some of this rope in there as well. There we go. Okay, that in theory at least should seal off that particular gap perfectly fine. Now that rope should be good to about 1250 degrees centigrade, which is more than this oven will ever go. So it should do us perfectly fine. Okay, it should serve us brilliantly. Okay, what this vermiculite tends to do, it not only does it give me extra insulation, it also helps me keep everything in place, because it sort of doesn't move or anything once it's compressed. So I sort of use it as a rough, basically if I squeeze everything together like I did these bricks over here and then pour vermiculite all over them, once I release the pressure they don't separate again, which is a very useful feature. Now that I've got pretty much everything in place now, I will pour my vermiculite. Okay, being rather careful where I pour it, because I want to be sure I cover all the areas that are exposed the most. For example, this over here, I only have the rope as insulation, so I'll make sure I pour it over here in a very healthy layer. Okay, because I want this to be insulated properly. Because remember, if you saw the earlier videos, this is the area where I had the most sort of heat leakage. I was able to sort of feel a little bit of heat over here, so I do have a feeling that this back needs some work. So I'm just going to pour this on, as well as on the other side as well, because God knows. Right, this is pretty much all the vermiculite I have. Ideally, I could use one more 5-liter bag, but you know, I don't have that much, so Okay, so a couple of things that need doing. First thing that needs doing is I need to be attaching this metal gang box to the end over there to cover up all the exposed terminals. Another thing is I need to be wiring the ceramic cable connectors into there as well, to make sure I can connect everything successfully and easily. There we go. What I've done over here, I've simply attached the angles to the gang box, so now I'll be able to mount it onto the sides. Simply, nothing complicated. Okay, everything. I've tried to make sure that everything stays very simple. Okay, and luckily enough for me, it actually has a ground terminal over there, so I'll be able to connect my ground from the power cable right to there, and then this whole structure will be grounded. Okay, which is a very good thing. I'm really quickly showing you what I've done over here because you can't really see it from your usual spot up there on the tripod. Okay, what I've done is, of course, I've wired the live and neutral terminals to the back of the oven, and I've wired the ground terminal over here, which in turn will make sure that the whole case is grounded. As well as this is a door interlock switch wiring. Okay, so it comes in through this orange cable right here and comes back out through this thinner black cable there and goes all the way to the front of the oven, back up again. All I need to do now really is attach this just like that. Okay, and of course put a thermocouple inside as well. There we go. What I've done over here real quick is I've attached that gang box. You can see the door interlock cable coming in over here. You can see the actual power cable coming in from the bottom, and this is the door interlock switch cable that goes down the front. Of course, this is the thermocouple, and I wanted to make this removable so it is not obstructed in any way, so I can just pull it out whenever I want to stash the control box away. That was the whole idea why I wanted everything to be removable in the first place. What needs to be done now is I need to install the door interlock switch once again. One more thing, I realized that I probably need another strip of this insulating rope just down the front here to keep any vermiculite I put on top from leaking out on me. So I'm just pushing that in. Okay, another thing is I need to reduce the spring tension over here because it is making it very difficult to close the door. There we go, it's a bit more like it. Looking much better inside now with very few gaps and everything else. Okay, so I imagine my kiln should perform better now. Okay, one more thing left to do is, of course, I need to be attaching this around the opening of the door to make sure that everything is sealed as much as possible, okay, when the door is closed. Okay, I couldn't find any nails, but what I did find is some staples, so I'm going to try to use those. I can't find my staple gun, so I'm just nailing them in one at a time and seeing how it works. Okay, just like that, and let's have a look if that actually works. Okay, and by the looks of it, that clamps everything down real tight, and I shouldn't have any more leaks of hot air through there, so I'm actually reasonably happy with this, so I'm going to leave it as it is. So there we are the following day, and what I did today, I went out and got another bag of vermiculite, a 10-litre bag, and that should certainly be more than enough to cover every gap that we have in here. So let's do exactly that at the moment. By the looks of it, this particular vermiculite is a bit coarser than the other one, but I'm pretty sure it will do this just fine. It's great. I'll be using this as a straight edge, so I can actually make sure that everything is level. Okay. There we go, and this way I can see that there's still some room for extra vermiculite to be added, so I'm going to do exactly that. Okay, I'm not worried about using too much vermiculite, because any excess that spills over, I can simply hoover it back up and put it back in the bag. and there we go. Okay, that's pretty much level now. And there's a full layer of vermiculite. Hopefully that will provide us with extra insulation to make sure that our kiln functions properly. And there we go. Now I need to add the lid and secure all the bolts and screws. Of course, now that the all the side walls are filled to the brim of vermiculite, they have expanded a little bit, and as such the lid seems to be a really tight fit. There we go. In theory, that should be good to go. Okay, all I need to do is hoover up a little more of that rubbish, stick the thermocouple inside, make sure that nothing leaked out inside over here. No. Okay, our fiber rope seals seem to be doing a pretty good job. Okay, and I think we'll be giving it a couple of test runs today. Of course, the beauty of this particular setup is that I can have my control box wherever I want around the actual kiln, you know, within reason, as far as the cables actually allow, because I can have it on the very top if I want. If I'm not, if I don't mind it getting quite hot, I can have it on the left, and I can have it on the right, in the front, behind, on the shelf. Doesn't really matter. Okay, so I'm really liking this idea of pretty much everything being detachable as well, because, well, I can stash it away. The sensitive control box, for example, can be stashed away on the shelf, while this one is sitting around on the actual table. What I'm going to be doing now is I'll run this kiln up to about 1100 degrees. It's going to be its first proper stress test. Another thing that, of course, I'll be measuring the temperature using my controller over here. I will be measuring the time as well. Probably I'll do another timer overlay for you guys so you can actually see the time. Another thing I'll do is I'll attach another thermal probe that I have right in the center right here, because I want to measure how good or bad surface temperature gets of this oven. Okay, while it's going up to temperature. Okay, we'll give this some time to actually cool down to its proper temperatures. In the meantime, what I'm going to do, I'll bring my laptop down here, create some room for it as well, and I will be recording the temperatures on a graph, on an Excel file, just so I can see how everything is going to turn out. Okay. Okay guys, so there we have our setup. Okay, we have of course our kiln, our control box that's fully plugged in but not powered on at the moment. We have another temperature probe right here that will be measuring temperature on the top of the oven, of the skin. Okay, you will be seated right over here in this little tripod, and right over here we have my laptop where I will be logging on temperatures every 30 seconds. Okay, every 30 seconds you'll hear a little alarm go off, and then at that point I'll be monitoring the temperatures. At some point I may go down to measuring them every minute or so, but for the first at least couple of minutes I'll be doing it every 30 seconds and afterwards I'll be plugging everything in and making a nice graph. There we go, 1100. There we go, we can press enter on that. So at time 0 we can see that our oven is at 13 degrees centigrade and our skin is at 18. I'm not sure why there's a difference, but we'll continue with it anyway. Right, so now all I need to do is I'll need to start my timer. There we are. And now I'm just waiting for the timer to clear. As soon as I hear the alarm bell, I will click the switch on and we will begin the test. 5, 4, 3, 2, 1, 0. Rather rapidly, so it's already 200 degrees and we're not even 2 minutes in. 6. Still 18. One thing I did forget to mention is we do have a what's called a test object inside the oven. Okay, it's a very small one, so it's not going to affect our readings at all. But I just thought it's going to be cute to show something that's going to be heated to 1100 afterwards. Whilst we're at it, we might as well talk about some safety precautions I've taken. One thing is I'm wearing safety glasses, okay, even though you can't see me. Another thing is I have a CO2 fire extinguisher ready to go, just in case. And if things really do go sour, I have a pre-charged water hose outside that I can knock the electricity out, and then I can just start hosing everything down. Right guys, well there we are. We've been on and off a couple of times. We are bordering at 1100 degrees centigrade. Skin temperature 52, which is not bad. Let's give it a try. Yep, it is pretty warm, but nothing out of the extraordinary, so it's not a hazard of any description. So, and very, very carefully, the handle is completely cold, by the way. Very, very carefully will we open this up. And there it is, ladies and gentlemen. Our oven, my camera is overexposing. Our oven at 1100 degrees centigrade. And in case you were wondering, this is how a bolt looks like at 1100 degrees centigrade. I am very happy with something like this. Right, we have a couple of issues. Our heating elements have drooped down and they have possibly short-circuited themselves. We'll have to be fixing that. Okay, but other than that, this is pretty cool. So I'm pulling this out. I'll set it outside. And you can see it's still glowing in the dark. This is pretty incredible. But now that it's cooled down somewhat, let's have a better look inside. I still have to distance myself from it because, well, it is still rather hot. So from what you can see, the heating elements have drooped down. Okay, they jumped out of their grooves. This is partly because of their heat expansion, I suppose, and maybe they weren't set in place properly. Same on the other side as well. Okay, another fun thing is, even though our glass fiber rope was supposed to be good to these temperatures, it actually melted away in several places, which is rather funny. Right, I have to close this door up because it's really hot. Phew. Right, there we are then. Okay, my camera actually got quite a bit hot. So, quite a successful test, I think. I've plugged in all the data into my computer and I have it all written down. So, what I'll be doing now, I'll be compiling it and afterwards getting back to you with all the information and analysis of the results. It took us about an hour and give or take 2 or 3 minutes to get to 1100 degrees centigrade. Alright, so guys, it's been another successful test. The oven did go quite happily. Even though it did take quite a long time, it did go quite happily to 1100 degrees centigrade and did stay at that temperature and continued there. And continued to stay there. However, there has been a couple of problems once again. The first problem is, of course, that you may have been able to make out that the heating elements have jumped out of the grooves and sort of drooped down. Couple of possible explanations for this. First is that they have not, well, obviously they haven't been nailed in place properly, and as they got hotter, they expanded and eventually had nowhere else to go but to jump down. Another thing is it could be that they are quite simply a bit too long. Okay, and because they're too long, as when they expand, they sort of start interacting with each other, and they have once again nowhere else to go, and they have to jump out of the groove. I will probably need to be disassembling the kiln again, okay, to rectify this issue. Another rather interesting thing we saw was fluctuation of performance. Most noticeably, it happened at 1070 degrees of temperature. It was at 1070, rising steadily by about 6 or 7 degrees every minute, and then suddenly it shot up in performance. What I think happened there is that as the heating elements sort of drooped down, or as they expanded, the coils started touching each other. And because they started touching each other, they have effectively short-circuited themselves out. Now, the shorter the element is, the more powerful it is. So what I'm guessing happened there is the elements became more powerful at that particular point because suddenly the coils could touch each other and more current can flow through. Okay, this may or may not be a problem. I mean, really it's a very good thing, because the hotter it goes, the quicker it goes, which would be rather nice. but that's not the intended function, okay? And I certainly don't want the heating elements drooping down and jumping out of their grooves, so I'll have to be rectifying this. Another thing is, of course, the glass fiber rope on the door melted, which is rather funny, if you ask me. I will have to look if it needs replacing, okay? Because really, what I have to consider is maybe the part that has melted was the one that is directly exposed effectively with the heat. Maybe the length of rope which is in between the two bricks right there, maybe that one isn't melted, okay? Once I take the oven apart, I'll be able to have a look at it. Also, insulation properties of the kiln seem to be rather good. I mean, it's cooling down at the moment. It's at 588 degrees and the skin temperature is at 72, okay? It is warm, it is hot. I wouldn't want to put my hands in it for any period of time. However, for a good half an hour, it stayed at 19 degrees flat, and it wouldn't go over that. After that, it was almost 800 degrees inside the oven, and outside it was 19 or 20. I'm really happy with the insulation properties. Okay, I'm really happy with the way this has turned out. And actually, oh yeah, the sides of the oven are hotter than the top, I think. Or at least as hot. So, you know, I've managed to spread the load across all four sides by the looks of things. Also, if I do decide that my heating elements are too long and I need to cut them to size, it's not as easy as just taking and chopping them down, because I have to consider the surface loading. If you did watch our maths video, you will know what I'm talking about, the surface loading of the actual element. Because not only will I be reducing the surface area, I will also be increasing the amount of power that it produces. Then, of course, I bump into the limit that I've set for myself of the maximum power of the oven. So I really need to be looking at this, okay, and how and where and how powerful I want, if I can make it any more powerful than this. It has been a successful test, sort of. You know, there's a couple of glitches here and there, but you know, as this is a work in progress, and as this is the first time I've actually did this, I'm quite happy with the way things are turning out. If I really needed to, I could run this tomorrow, okay, but I will still put in a little bit of work to make sure this runs perfectly fine, and I'll probably be showing you what I'm doing and how and where I'm doing everything in the next part. Hopefully we're pretty much at the end by now, okay, nothing else will go wrong. But for the moment, thank you very much for watching. Have a lovely day. Take care.